All right. Hello and welcome, everyone. Thanks for choosing to attend my session here. Pretty excited to talk about the Ceph notification v2, all the enhancements that went into the existing bucket notification to make it an enterprise-level feature. So I'm here to talk about the feature v2. Uh, uh, Before I start my session, I just want to go through the agenda. I'm going to talk who we are. Going to talk about our multi-site Ceph clusters. Then try to pivot towards the bucket notification, what the existing notification or feature looks like. And then jump on from there, what all enhancements went into to make it to V2. And then open the forum for more questions. All right, so I'm Krunal Chheda. I work at Bloomberg. Most of you guys would have heard about the Bloomberg. Bloomberg is a financial technical firm, technology firm. It basically develops tech products which caters to financial market. Talking about financial product, people would have heard about the Bloomberg Terminal. It's the flagship product of Bloomberg, which is basically subscribed by more than 350,000 people, 350 institutions, I would say here. And that terminal basically provides all the financial news, financial analytics, and financial data to all of these institutions at real time, which help them to take informed decisions. At Bloomberg, we have more than 9,000 engineers, and those engineers are basically categorized into an application engineer and an infrastructure engineer. So the application engineers usually are the ones who are developing applications for the end users, and then the infrastructure engineers are the ones who provide the necessary infrastructures required by the application users to consume. And as a part of I belong to the infrastructure engineering group, where we provide or we cater all of the storage needs for all of our application engineers at Bloomberg. As a part of storage org, we design, build, and maintain all of our storage at Bloomberg. And of course, because we are part of the storage org, we try to cater to our to file storage, block storage, and object storage. Along with the file, block, and object, we also provide the workflows for automations. We provide backup to our other teams. Those are the extra services that we provide as a part of storage org. And inside the storage org, again, I belong to the storage distributed team, which basically provides the object storage to our application engineers. The object storage, again, is an S3 object storage, and no guesses here. That is supposed to be backed by Ceph. Along with the object storage, we also consume the vanilla block storage of Ceph, which basically powers our OpenStack cloud, and that is part of our compute team. So you can see that we are pretty much heavily rely on Ceph for our block storage needs and our object storage needs. Since this talk is about the RGW feature, I'm going to concentrate more about what our gateway or S3 clusters look like. So currently, we have 10 clusters, which is spanning across 4 data centers, basically 4 geographic locations. And we cater to almost 77 petabytes of data across these clusters. Our largest cluster has close to 4,500 OSDs, and it has more than 2,000 tenancies, and which constitutes of more than 450,000 buckets. So as you can see, all of these together, when put together, we get close to 2 billion requests daily. So when you look at the scale, we are not only big in terms of storage capacity, but also in terms of usage, because the users that use these are not kind of retail users. These are the application users which spin up Hadoop system or other system. They basically are machine users, and which kind of send us multiple requests, thousands and thousands of requests at any point of time. So because we are so heavily used, it becomes essential for us to open any feature to our team has to be properly tested. It needs to basically cater, it has to be a fault tolerant. It has to provide enough metrics so that in case things go sideways, we are in a position to control the system, and we do not have a bigger outage. So talking about that, I'll move on to the discussion to give a gist about what the current notification looks like. So bucket notification was already a feature in Ceph before this, and it is a pretty powerful tool, and it is an AWS feature. It is a pretty powerful feature which allows your clients to run their automation workflows. So it's an event-driven workflow where as you can see in the diagram, right? You would have a bucket where you would have subscribed saying that I want to get all the events that happens on these buckets. So the question is, where do you want those events? So there would be a broker where the gateway would try to send all the events that happen on that bucket to that particular to the broker. And as an automation workflow, you would have your system or a service listening to the broker. And that broker, as soon as you get any event, you would trigger your following workflow. So a classic example was shared, or use case on what bucket notification can be used was shared by Yuval in previous Cephicon about data backup workflow. In a typical data backup workflow, what you would expect is you would want to back up your buckets. So what you would do is you would read your bucket, come back again at a fixed interval, probably a day later, try to read the bucket again, see what objects have been added and what objects have been deleted, and then you go and try to back up those objects again. As we have seen in some of the talks, listing bucket is pretty expensive operation. So bucket notification basically leverages, helps solve this big problem to a big extent. You could set up a bucket notification on a bucket which you need to back up, and you would have your backup system or your backup services hooked up to your broker. And as soon as there is an addition or a deletion of any object on that particular bucket, you will have an event that gets triggered, which is received by the broker, and your backup services would then take up the action. So it completely eliminates the need for your backup services to actually read the bucket every time there is a new object added. Talking about that, Ceph today provides two types of bucket notifications. One is synchronous notification, and the other one is async. As the name suggests, the synchronous notification basically is as and when you have an S3 operation happening onto a bucket, the notification would be triggered along with at the same time. So basically what that means is your latency to deliver the event to the broker is added on to your S3 latency. So for people who are latency sensitive, they can opt in for the async notification. As the async notification suggests, the notifications are not sent straight away. What happens is as soon as there is an S3 request, you would have your event get stored into a queue in the backend, and there is a backend process which keeps on reading this queue and then dispatches those events to your broker. Talking about broker, Ceph today, our gateway supports three types of brokers, which is the Kafka broker, AMQ broker, and HTTP broker. So that topic A, which you see here, that is broker, and then you have bucket and notification hooked up to your bucket here. The different events that Ceph supports today are broadly categorized into these four events. The object create. So any put operation, post operation, or a multi-part operation, they all get categorized under object create. Object delete or post delete, they all get categorized into object remove. All of the lifecycle events, so you could have an version object, expiry of a version object, or you could have non-current days, or you could have a deletion of delete marker. All of those events gets categorized into lifecycle, and you would get notified whenever an action gets taken place on that bucket. And of course, the replication. So you would have a replication create and replication delete. So this is the use case where you can use your backup system could be listening onto your replication side and try to copy the things from as soon as it gets replication events. So this was the existing, or this is existing bucket notification feature. So this feature was already there, but the feature, as the title suggests, that the new feature V2 is an enterprise level feature, right? So when we say an enterprise level feature, what are we talking about? So what we are talking about, the feature that scales well, it is fault tolerant, provides enough telemetry, and is secure. So all of these features are probably, to make it as an enterprise level feature, the corresponding enhancements that were added are being listed here. And I'm going to talk about all of these enhancements individually in detail in each of the different slides here. So first one, ownership and permissioning model. So as the name suggests, right, as a part of V2, when you create a topic, right? So creation of topic is basically telling Ceph, this is my configuration for the broker. This is how you're supposed to connect to the broker. It provides you with the credentials. So that topic which is created inside the Ceph did not have an owner in V1, right? As part of V2, now the user who creates a topic is by default the owner of that particular queue. Think about it like you have a bucket and there is no owner to the bucket, right? That definitely sounds scary. That means is any user could come in, and suppose a user goes and creates a topic A, and there could be another user who doesn't know the topic A exists and goes and tries to create again a topic A, and the original user was using Kafka, probably the user 2 is now using AMQ. What happens now is your topic A under the hood is now modified, and it would be sending all the notifications not to Kafka but to the AMQ. So what would happen is, and a user, now both the user A and B would have their events being sent to the AMQ, and when the event is sent, you have all the object information, the bucket information being shared. So it's pretty scary being a storage provider. Think about that. You have two different users, completely separate users, but the user 2 is able to get all the information about the user A. So it clearly kind of violates the security. So that was one of the biggest, or the first feature that was added as part of V2 is to associate an owner with the topic. Of course, if you associate an owner, then of course comes the permissions. There would be use cases where you would want to share the topic, where you would want to give the permissions for the other user to look at the topics, right? A classic use case could be where two users want to collaborate, and the user 2 wants to look up all the events that are happening on to a bucket, right? The user can share a bucket with user A can share a bucket with user B, right? User B wants to get notified about all the events that are happening on user A. What user A would do is just give a subscription, or probably say that would give the subscription ACL to that topic, and then the user B would now be able to log on to the broker 1 and then look up all the events. So that's a use case where you would want to share the permissions to look up topic. So currently, we share 3 permissions, which is you can you view the topic, modify the topic, and whether you can subscribe to the topic. So those are the 3 granular permissions that V2 allows you in terms of sharing the topic. The next one was multi-site syncing, right? This one was pretty important for us because, as I said, at Bloomberg, we have our clusters set up in multi-site config. So think about this way, if we had to tell our users, hey, when you create your topic and create your notifications, you have to do 2 separately since we have 2 zones. If people have 3 zones, they will have to do thrice. That you have to do once for every zone. So if you are in V1 today, and if you had to set up a notification for your each zone, you would have to go individually and set up notification and topic on each of those zones. That doesn't give kind of right experience to our end users, right? So what, as a part of V2, we did was we added the multi-site syncing capabilities to the topic and object. A little detail on that was we basically made the topics to be part of metadata. By default, your users, whenever you create any users, you create buckets, you create roles. Those are called as metadata operations. And by default, any metadata operations are synced across different zones. So now, and as a part of V2, the topics are also considered to be as metadata. And so as and when you create your topic onto your master site, it automatically gets replicated to your secondary zones. Talking about bucket notifications. Bucket notifications originally were again stored as a Rados object, but as a part of V2, now they are stored as bucket attributes. And by default, bucket attributes, whenever you modify any bucket attributes on your primary side, it automatically gets synced to the secondary. So with this enhancement as part of V2, we achieved the multi-site syncing. So now if user has to set up, all that user has to do is go and create the notification and the topic once, and it is automatically gets synced up to all of the zones. And then if there is any activity happening on the other zones and you are subscribed to those events, you would automatically get the notification. You don't have to go and again explicitly create on each zone. The next one is telemetry and insight. This is a pretty important feature for us or for any enterprise user you talk about. You talk to any operator, right? They would often, a storage operator, they would say that they want enough telemetry or they want enough perf counter. As we look at the previous talk about the perf counters, right? You want all the details that are happening in the system, and so that you can take any action in an event something goes sideways, right? So same thing with notification. You would want to think what are the options that could go sideways, right? So in persistent notification, as I said earlier, you have a queue where an S3 request comes in, and then the event is stored into the queue, and then there's a background thread which goes and reads the queue and then dispatches those events, right? I wouldn't say unfortunate, but by design, that queue is a limited size queue. So the size of the queue is 128 meg. So you would think is, what would happen worst case? The queue getting full, what will happen is you would not get notification. But that's not it. This was a purposeful design that persistent notification had to be a reliable notification. So if you subscribe to persistent notification, you have to have deliver. You need to get the notification at any cost. So for that matter, this was a design decision where if the queue gets full today, your S3 requests are blocked. So this could be a very touchy experience. Think about a user who has subscribed to notification, and all of a sudden, even the user has quota, has all the necessary permission on the bucket, and that user tries to write to a bucket or tries to delete any objects from the bucket, and then the user gets an error, 503. The operation is not, slow down for the operation, right? It's not obvious what's gone wrong here. Would be absolutely nice if there was some telemetry associated that things have gone wrong, right? I mean, I could talk about why the queue can get full, but broadly, the queue can be full either because the Ceph is not doing what it's supposed to do, the background thread is not doing the work correctly, or there could be the broker is not configured correctly, and what that means is the notifications are not being sent to the broker and they're still being held on to the queue. So what that means is queue getting full, user getting a lousy experience that they are not able to do any operations on their bucket, right? So as a part of V2, the new command that was added was Rados gateway admin topic stats. What that does is it basically spits out the number of entries that are pending inside your queue, and it spits out the size. So once you have these two numbers, and these two numbers are also exported via the perf counters, and once you have these numbers, as an operator thing, you can just use those numbers to set up alarms. So think about it. You can set up alarm saying that the queue has gone to 70% full, and you could set up an alarm for the operator to go and look what's going on. Either some Ceph is not what, or the gateway is not doing what it's supposed to do, or is there a broker not being configured correctly by Ceph, or the users have not shared the correct information while setting up the broker, right? So you can take the necessary steps and then accordingly avoid the scenario where you have blocked the writes to the bucket. So that was a very important telemetry insight that was provided as part of V2. The second one was topic bucket mapping, right? As I said originally, you have a topic and you have a notification. Both of them, you first create a topic which basically says, this is my broker, and then you create a notification onto the bucket saying that I want to subscribe to XYZ events, right? When you go and create notification, you always know that which topic you want to send to. But it's not true the other way around. A topic, when you try to get a topic, you don't know what all buckets are associated to that topic, right? As an operator, again, this is a pretty useful information. If you want to list a topic or you want to get any topic information, you would also want to know what all buckets are associated to that topic, right? So this topic bucket mapping now allows you, or probably it displays the information as soon as you try to get a topic, get info on a topic, it would display also all the buckets that are hooked up to this particular topic. So it is a nice to have feature, I would say. Then finally, the new log subsystem. This is something I had talked in my previous talk at Cephicon as well. People, or probably operators and developers, they know it is super hard to debug a distributed system. And Ceph being a beast here, if you have to debug anything, you turn on debug RGW20, you are pretty much doomed at this point of time because you don't know how do you grep or what do you grep and amount of data that you need, or probably the file system size that you need to store that amount of data, right? So it becomes a no-brainer as a developer that whenever you develop any new feature here, you would want to associate that new feature with its own log subsystem, right? What that means is, Tomorrow, if there is any issue in that particular subsystem, you can just turn on the debug logging only for that subsystem, and you don't need to turn on the debug logging for your entire gateway. So same thing applies here. The new log subsystem which was added is RGW notification. What that means is if you want all the debug logs for only specific to notification, all you need to do is turn on debug underscore RGW underscore notification. You don't need to turn on the blanket debug RGW, and that will only spit out logs specific to notification. So that's a win-win situation for developer as well as an operator, because it's much more narrower for you to now look up what logs that you are interested in. Talking about control persistency, right? As I said originally, you want your system to be fault tolerant, right? So this pretty much nicely ties with it. One of the features I said earlier about the persistent notification was that it guarantees you a delivery. But there is a kind of fine line that you want to decide whether how do you want the delivery, how often do you want, like how many attempts do you want to try before you try to give it up, right? You don't want a system where you have set up your configuration incorrectly and then gateway to keep on try send notification where the notification is of course going to fail because the configurations are not correct, right? Everything has a cost associated to it. These background threads which are going and processing queues, they definitely are using your process and memory. Of course, they're not using to that extent, but they are still using it, right? So as an operator, you still want to have that decision making in your hand or as a lever that what to do in an event where the notification is not being able to be sent to the broker, right? So in that event, the two configs that were added as part of V2 are time to live and max retries. Again, as the name suggests, time to live is basically you provide in the time, and as and when the event is created and stored onto the queue, you basically you store in the start time or the start time or the time when it was created, and then at the time when the events are sent as a part of background thread, you look up whether the TTL has reached for that particular event, and if the TTL has reached, you basically evict the entry from the queue. So this way, you are basically saving, you're not doing a continuous retry forever and ever for events that are not going to get delivered. And same thing with max retry. Max retry would give you an option how often do you want to retry. The reason for providing two options is max retry is not persistent. When I say not persistent, is if your gateway restarts in the middle or crashes in the middle, the max retry, the retry count goes back to 0. So in that event, if there could be a bug where while sending notification, your gateway is crashing, and if you have not sent the time to live or you have not set TTL, your events would still not be evicted, and every time it gets restarted, the max retry goes to 0, and then it keeps on retrying forever. So as an operator, you would want to fine-tune that and have both the values set correctly. And the retry sleep duration is basically just how often you want to sleep between the multiple retries here. And finally, talk about some performance improvements that went into V2. The first one is an async write to the queue. As the persistent notification is, we go and write to the queue. You have an S3 request, you go and write the data, or you write the event to the queue. Originally, writing of that to the queue was part of the S3 request. So that teeny-meeny added onto the S3 latency. As a part of V2, what we've done is we've spun up another thread in the background which goes and does the write to the actual queue. So that helps in a bit of S3 latency. So this performance is not specific to sending event. It's more towards the S3 latency, which is getting improved here. Same thing with the second one, the individual Rados object, right? This is more like a design change, and the performance was an outcome and byproduct of this particular design change that we did. In V1, the topics and notifications were stored as one giant blob. When I say one giant blob is you had one Rados object which stored all the topics for the entire system, right? So you could have a user A has a topic A, then you have user B topic which has topic B. They both are stored together in one single Rados object, right? What that means is if you want to read an object, you are trying to get an info about that object or of the topic, you are basically unpacking the whole Rados object, trying to go and list through all the topics and then find your topic and then return back. So of course, it's going to be comparatively a time-consuming operation versus in V2, where now each topic is now stored as a single Rados object, right? So all you need is to go and query that particular object and get the information about that object. And same goes to bucket attributes, right? You just have to load the bucket and the attributes are loaded automatically versus originally all the bucket notifications were stored as a single Rados object. And then if you want to load any notification, you're basically loading that bucket object. So that was another, again improvement, but not towards the sending notification, but in a way of reading, or if you want to look up any notification or look up any topic. And finally, again, the caching of the Rados object. So this is, again, another byproduct of the change or the design change. As I said originally, the topics are now part of the metadata in Rados object. And the current code in Rados is anything that is specific to metadata is cached. So when you do any subsequent reads, it does not go to the disk and tries to read it from the cache. So if you're trying to read the topic, which you do while sending, or you could, when you do a get, you would not go to the disk and you just inherently read it from the cache. So this basically talks, or all of these enhancements that I just spoke, they kind of tie up on how your enterprise feature would look like. As I said, it has to be fault tolerant, it has to be secure, it needs to be well stable enough, and it needs to provide telemetry. So all of these enhancements kind of nicely tie up for this notification to be called an enterprise feature, right? Now, you need to go and take a step ahead and think from operators' mindset, from the operator's shoe, right? What about people, if people want to onboard onto V2, right? What about people who already have the topics, right? So for them, what we did was we set up an auto migration, right? Since this feature is only part of Squid, or it starts from Squid, people who want to onboard onto this feature would still want to migrate all of their existing underneath topics or underneath bucket notification as well. So what we did as part of migration is we created a background thread. And what happens is, when you turn on this particular feature, a background thread goes and tries to read all of your topics and notification under the hood, and creates them into a V2 mode. When I say create them into V2 mode, is create those individual objects and store them into bucket attributes, where the notifications are stored, right? The good part is, while this is happening, and if the user who has subscribed to notification would still transparently get their notification, it no ways is a blocker for the notification going in. So it's, again, a nice for people or for the operator not to go and ask to have a downtime for notifications, right? So the only downtime would be, or as mentioned here, is it blocks the user from modifying their users or modifying their topics and notification, which is, but of course, right, you are trying to migrate your existing topics and you don't want to change that topic while you're migrating. So while the migration is going on, the modifications to topic and notification is blocked and the user gets 503. I actually kind of missed one point here. When I said people want to migrate here, right, the migration wouldn't start as soon as you upgrade to Squid. That would be scary as an operator, right? You want the full control on when you want to migrate your topics, right? So the reason for us, so to achieve that, what we have done is we have made the V2 feature as a zone group feature. So for folks who don't know what the zone group feature is, a zone group feature is a feature which gets enabled only when all these zones in the given realm or in the given zone group agree to enable it. So if I'm in a multi-site with 2 zones, unless and until both the zones do not enable it, I cannot start this, or this feature cannot be turned on. So for folks who are looking to turn on this feature, they would have to go and turn on the zone or turn on the feature on each of those zones, and then do a zone group period commit, which would basically then go and pick up this particular feature and turn it on. And as soon as this feature turns on, the migration goes in, kicks in, and migrates your topic and notification. Another thing is support for user accounts. As most of the folks here would have heard about, the major accomplishment as part of Squid from Gateway was support of user accounts, or support of IAM. So as soon as you have an IAM, you would also want your notifications to support. So if there is an account user creating notifications, you would want the notifications to be supported. So as a part of that support, when account user goes and creates a topic or creates bucket notification, the account's root user is stored as a part of ownership. The account root user is stored into the topic. So there could be multiple account users for a given account for a root account, but only the root account would be stored as a part of storing the ownership here. So that's the support that has been added for user accounts as well from the notification front. So I guess that pretty much sums up all the enhancements that have gone into this. There are a couple of plans, or at least a couple of trackers there for the future work. The first one is the conversion of the queue from cyclic to FIFO. As I mentioned earlier, the current queue size, that is 128 meg. You cannot go beyond that. So there could be scenarios where you want your queue size to be more than 128 meg. So the option is to convert your persistent queue from being a cyclic queue to a FIFO queue. So there is an open tracker for that as well. And the other use case is a pretty interesting use case is in the multi-site sync, by default, V2 supports multi-site syncing. But there could be a use case where you have two zones in completely different zone group, completely different geographic locations, and they have their brokers completely in different locations. What that means is because of, as an adverse effect of multi-site syncing, you are only allowed to set up one broker at a time for a given topic. So that topic, the same broker will get synced to the secondary zone as well. So if the secondary zone wants to send to a different broker, there should be a way or provision for that, and that's what this tracker is going to deal about. So those are the two open items. I would highly encourage other people or the other operators to start using this particular feature whenever you get a chance, whenever you guys upgrade to Squid. As at Bloomberg, we walk the talk. We already have this feature in-house. We already have this feature enabled in our production world, and we have started using this. And as a developer, you would always want feedback whenever people use it. That's the actual feedback versus any feedback that how much ever testing you do, but the feedback that you get from the live usage is no comparison to it. So I highly encourage people to go and use this particular feature. And that brings end to my topic, and open to question at this point in time. I think we have 3 minutes for questions. Yeah.
For the ACLs, topics, what format is it? Is it like bucket policies?
It's the same as bucket policies. The way you give it bucket policies, the same way you can provide the ACLs for the topics as well. Sure.
The bucket attributes, you said you store the notifications in bucket
Attributes.
So what do you store in the bucket attributes? Is the notifications itself or
The entire notification is stored as a bucket attribute there. The configuration, yeah. In the queue, but the attributes, yeah. On what events that you need to send, and all those configurations are stored as bucket attribute.
I have a question about performance.
Sure.
What is the difference between bucket with enabled notification and without notification? Performance for writing or
So we definitely saw a difference in performance of our, when I say performance, you're talking about the S3 latency here? Or?
for example, how many writes per minute per second I can achieve with enabled bucket with enabled notification and without?
So in our testing, we definitely observed a difference in number of buckets or probably number of operations for a given interval that you can do. So if that bucket did not have any notification set on it, definitely has more latency, or probably you can write more faster, or you can do more operations on it as compared to a bucket which has notification hooked up to it or subscribed to it.
Maybe I'll try to.
Yeah, sure. Yeah. You all, yeah, please.
So, notifications but the queue is not.
Not.
So I think one thing would be nice to add to the future plans from the previous slide would be to have a sharded, not only a longer queue for longer outages of Kafka, but also a sharded queue to allow parallelism with the writes of application.
And I'm guessing once we move on to 5.4, you automatically get that sharded because the 5.4 queue, maybe?
Not exactly. 504Q allows you, it's like a linked list of queues.
Yes.
So it allows you a much bigger queue for larger outages of Kafka, but doesn't improve the performance by far.
Yeah.
And this is really the performance issue. Reading from the queue and sending notification, because Kafka is very fast,
Is not a problem. Yeah. Writes.
right. So the FIFO has some kind of NQ and DQ, but not simultaneous NQs. And I think this is
This is what the question is, yes. All right. Thank you once again for attending my talk.